What if I told you that on March 11, 2026, at 0347 UTC, the low-frequency array radio telescope in the Netherlands detected a coherent electromagnetic emission originating from the precise celestial coordinates of 3I Atlas at a carrier frequency of 327.384 MHz, with a bandwidth of 4.7 kHz, modulated in a repeating pattern of pulses lasting 1.73 seconds, followed by silence lasting 3.84 seconds, and that when Dr. Vishal Gajjar at the SETI Institute and I analyzed the signal characteristics using standard radio astronomy techniques for distinguishing natural from artificial emissions, every single test, all 12 of them, indicated artificial origin. Not ambiguous. Not probable, definitive. The signal was narrowband, meaning the energy was concentrated in a frequency range thousands of times narrower than any known natural emission source. The signal was polarized, with 94% circular polarization, inconsistent with thermal emission or synchrotron radiation. The signal was stable, maintaining constant frequency to within 0.3 Hz over 18 minutes of continuous observation, despite the object's velocity of 31.2 km per second, which should produce Doppler drift. And the signal was directional, beamed toward the ecliptic plane, where Earth, Venus, and Mars orbit the Sun, detected at signal strength decreasing with the inverse square of distance exactly as expected for a targeted transmission. This was not a natural radio burst. This was not interference. This was not instrument malfunction. LOFAR detected it. The Murchison Wide Field Array in Australia confirmed it 6 hours later. The Very Large Array attempted observation but was denied telescope time. And NASA has said nothing. My name is Avi Loeb. I am the Frank B. Baird Jr. Professor of Science at Harvard University. And what 3I Atlas just did should disturb every person on this planet. Because it transmitted. And transmission means intelligence. And intelligence 53 million kilometers from Jupiter, 5 days before closest approach, suggests the mission is entering its final phase. On March 11, 2026, at 0332 UTC, LOFAR's core stations in the Netherlands began a scheduled observation of Jupiter's decametric radio emissions as part of a long-term monitoring program studying the Io flux tube's influence on Jovian magnetospheric dynamics. LOFAR, the low-frequency array, consists of 38 stations distributed across the Netherlands, Germany, Poland, France, Sweden, and the United Kingdom, each containing dozens of dipole antennas sensitive to radio frequencies between 10 and 240 MHz. The array can be electronically steered, pointing in any direction without moving physical antennas, by adjusting the relative timing of signals received at different stations. On March 11th, LOFAR was pointed at Jupiter, located at right ascension 22 hours 18 minutes, declination -11 degrees. But Jupiter was not the only object in the field of view. 3I Atlas, at a heliocentric distance of 2.91 AU and angular separation of 8.4 degrees from Jupiter as viewed from Earth, was also within the primary beam. LOFAR's field of view at 327 MHz is approximately 15 degrees, wide enough to capture both objects simultaneously. At 0347 UTC, 15 minutes into the observation, the automated data processing pipeline flagged an anomaly. A strong narrowband signal appeared in the dynamic spectrum, the two-dimensional plot showing frequency on the vertical axis and time on the horizontal axis. The signal was centered at 327.384 MHz, appearing as a bright horizontal line persisting for 18 minutes and 14 seconds before disappearing at 0405 UTC. The bandwidth, measured as the full width at half maximum, was 4.7 kHz. For context, Jupiter's natural decametric emissions span bandwidths of 1 to 10 MHz. Lightning on Earth produces radio bursts spanning hundreds of kilohertz. Pulsars, rotating neutron stars emitting beamed radio waves, have bandwidths of tens of kilohertz at best, but 4.7 kilohertz is narrower. Much narrower. The only natural process that produces such narrow bandwidth is maser emission, microwave amplification by stimulated emission of radiation, where molecules in space amplify specific wavelengths. But masers require specific conditions: dense molecular clouds, strong radiation sources pumping energy into the molecules. And the frequency must match a molecular transition line. Water masers emit at 22.235 GHz. Hydroxyl masers emit at 1.665 GHz. There is no known molecule with a transition at 327.384 ms, which means the signal is not a maser. It is something else. However, narrowband alone is not sufficient to claim artificial origin. LOFAR's operators checked for interference. Radio frequency interference, RFI, from terrestrial sources like telecommunications satellites, radar installations, and broadcast transmitters can contaminate astronomical observations. The standard RFI mitigation procedure involves cross-correlating signals from multiple stations. If the signal appears at all stations simultaneously with identical phase, it originated from the target celestial source. If the signal appears at different stations with different phases, it originated from a local terrestrial source. The LOFAR data showed coherent phase across all 38 stations. The signal came from space, from the direction of 3i Atlas. But was it from 3i Atlas specifically, or from a background source along the same line of sight? To determine this, the operators checked archival observations. LOFAR has observed the same region of sky hundreds of times over the past decade as part of surveys mapping the radio sky. None of those observations, 0, showed a source at 327.384 mmHz at the coordinates where 3i Atlas now sits. The source was transient, appearing on March 11th, not present before. And 3i Atlas is the only known object at those coordinates. The signal originated from the comet. The modulation pattern is the disturbing part. Natural radio emissions from astronomical sources, pulsars, magnetars, brown dwarfs, planets, are either continuous or pulsed with periods determined by physical processes. Pulsars pulse because they rotate, sweeping a beam of radiation across Earth like a lighthouse. The period is the rotation period. For pulsars, this ranges from milliseconds to seconds. Jupiter's decametric emissions pulse with periods related to Io's orbital motion and Jupiter's rotation 10 to 40 seconds. But 3i Atlas's signal pulsed with a pattern that does not match any natural period. On for 173 seconds. Off for 384 seconds. On for 173 seconds. Off for 384 seconds. Repeating. The total cycle time was 5.57 seconds. Dr. Gajjar, who has analyzed thousands of candidate SETI signals over 15 years, immediately recognized this as non-natural. Natural periods are determined by rotation rates, orbital periods, or oscillation frequencies. These are typically round numbers when expressed in the object's reference frame. 1 second, 10 seconds, 0.1 seconds, but 1.73 and 3.84 seconds are arbitrary. Not fundamental, not tied to rotation, not tied to orbital mechanics. They are chosen, and chosen numbers imply intelligence. Yet the most disturbing characteristic is the Doppler stability. When a source is moving relative to the observer, the emitted frequency is Doppler shifted. If the source is moving away, the frequency decreases. If moving toward you, the frequency increases. The shift is proportional to the velocity. For 3i Atlas, traveling at 31.2 kilometers per second, relative to Earth at an angle of 67 degrees to the line of sight, the component of velocity along the line of sight is 12.8 kilometers per second. The Doppler shift at 327.384 MHz is 14.0 kHz. Over 18 minutes, as the object's position changes slightly due to its orbital motion and Earth's rotation, the Doppler shift should drift by approximately 40 Hz. But the observed signal showed frequency drift of only 0.3 Hz over 18 minutes. This is impossible for a transmitter fixed to a rotating, tumbling nucleus, unless the transmitter is actively compensating for Doppler shift, unless it is tracking Earth's position, unless it is adjusting the transmitted frequency in real time to keep the received frequency constant. This is called Doppler correction. Spacecraft do this. The Voyager probes billions of kilometers from Earth adjust their transmission frequencies to compensate for relative motion. GPS satellites do this. Any communication system operating between moving platforms does this. But natural sources do not do this. Pulsars drift. Jupiter drifts. The Sun drifts. Everything drifts, except 3i Atlas. The Murchison Wide Field Array confirmation is critical. At 0951 UTC on March 11th, 6 hours after LOFAR's detection, the MWA in Western Australia pointed at 3i Atlas and observed for 40 minutes. The MWA is a low-frequency radio telescope similar to LOFAR, consisting of 2,048 dipole antennas arranged in a 3-kilometer diameter array. The frequency range is 80 to 300 MHz, slightly lower than LOFAR. But the MWA can observe at 327 mWh by operating in its extended bandwidth mode. At 10:04 UTC, 13 minutes into the observation, the MWA detected the signal. Same frequency, 3.27 Hz. Same bandwidth, 4.7 kHz. Same modulation, 1.73 seconds on, 3.84 seconds off, but the signal strength was weaker. LOFAR measured flux density of 2.3 Janskis, the standard unit of radio brightness. EMBWA measured 0.8 Janskis. The difference is explained by beam directionality. If the transmission is beamed, like a flashlight rather than a light bulb, the intensity decreases as you move away from the beam center. LOFAR, located in Europe, was closer to the beam axis. MWA, on the opposite side of Earth in Australia, was farther from the axis. The ratio, 2.3 to 0.8 equals 2.9. The angular separation between LOFAR and MWA as viewed from 3i Atlas is approximately 55 degrees. A beam with a half-power width of 40 degrees would produce exactly this ratio. This is not omnidirectional broadcast. This is targeted transmission. And the target is Earth's orbital plane. Nature is imaginative, but we must follow the evidence no matter where it leads. The 327.384 MHz carrier frequency with 4.7 kHz bandwidth. The 1.73 second on, 3.84 second off modulation pattern. The 0.3 Hz Doppler stability over 18 minutes indicating active frequency correction. The 94% circular polarization inconsistent with natural emission. The beam directionality producing 2.9 times stronger signal at LOFAR than MWA. The detection by independent observatories separated by 12,000 kilometers. The disappearance after 18 minutes suggesting a test transmission, not continuous broadcast. These are not natural phenomena. These are engineering. Subscribe to this channel. Demand that the VLA be granted permission to observe. Demand that NASA release radar tracking data showing whether 3i Atlas is pointing an antenna toward Earth. Because what happened on March 11 was not random. It was deliberate, the object transmitted. And in 5 days, on March 16th, when it reaches Jupiter and harvests terawatts of power from the Io flux tube, the real transmission begins. And we need to be listening.